So, hello, and thank you for coming to my talk about how to apply AI to testing. What I'm going to talk about is really how to test software using AI. So there are many potential ways you could use AI in testing, like for bug triaging, test prioritization, test maintenance, and so on. But today I really want to talk about how you can test your software using AI. So like applying IBM Watson to do that. But from a developer's perspective, testing sometimes is described as a destructive process because developers like to say that testers break their code. So for them, it probably more looks like that. When you apply Skynet to testing to fiercely attack your software and break it. But either way, this is a very hard thing to do. And why is this the case? Well, if you think about how testing works, so I have a given software and I ask, like you, is this value correct or not? Then you have to say, you don't know. Okay, you can't even see it. Okay. If you could see it, you still wouldn't know, because you don't know what the program is about, you don't know what it does, you don't know what it's supposed to do. You don't know what input values were given and how it's configured. So you have no idea of knowing whether this value is right or not. And with AI, it's the exact same situation. So if like Watson or Skynet or whoever wanted to test the software, the AI would have to decide whether this value is right or not, and it couldn't know. There could be a bug directly in front of you and you wouldn't even recognize. Like, do you see the bug in the picture? So that twig in the front is actually a beetle, is a bug. And it's hard to see, and the same is true for an AI. And this is called the oracle problem, like from the Greek mythology, the Greek oracle that can tell the future. We would need an oracle to tell us whether the value is right or wrong. And this is an unsolved problem, which makes it hard to bring AI into testing. It's actually so hard to do that people say, like the CTO of Test Plan says, AI in testing is so far nobody's doing it in a useful way. And the CPO of Tricentis even says that AI in test automation is a hype. Well, this kind of reminds me of that quote, which you may know or not. The CEO of IBM at some point in time thought there would be a world market of maybe 5 computers. I think we exceeded that. And same applies to testing. So I think AI in testing is the future. So how do we solve that problem if it's so hard? How can we go about it? Well, what is the goal of testing? The goal of testing is to find bugs. Okay, then what is a bug? Or when is a bug a bug? Well, if it's not a feature, right? So you see that beetle on the plate, it reads feature, you can't read it, sorry, it's so small, but it says feature on its plate, so this is not a bug. And I have some popular examples. So when Linux was developed, at first it didn't have, it had a very primitive file system, and all the files were in one level. And then there were too many files, and people wanted to structure that. So they implemented a tree file system with multiple levels. And then they, because everything was command line based, they put the dot and dot dot operator to reference the current level and the parent level. And then there's the command ls, list files, and that command treated those as if they were actual physical files. So they adapted the ls command and put in the following line. It's just a single line, and it says if the first character is a dot, ignore the file. Like in a loop, continue with the other files. But now, of course, you can rename a file to have the first character being a dot, which makes it disappear. So by accident, they invented hidden files. And because the feature was so popular, they never fixed it. Now you have to put ls-a, show all files, to also show the hidden files that start with a dot. And there's this famous game Space Invaders, where you have a small spaceship at the bottom that shoots at the aliens at the top. And the more aliens you kill, the faster the game gets, the faster it becomes. And this also was not intentional. This was not designed that way. It's just that at the time, the hardware was very much less performant than today, and the fewer elements it had to render on the screen, the faster it got. So it became faster, the more aliens you killed. And because this was a good feature, they, let it be. And you probably know Google Mail, and they have this feature where you can send an email and then click undo, like, oh, forgot the attachment. And this also was not intended that way. So with Google, everything is service-oriented, and when they wanted to publish that functionality, the Google Mail beta or whatever it was, and they had the problem that the mail took some time to go through all of their services. So they thought hard how to work around that, and then someone came up with that idea. So instead of making the services faster, they just gave you the option to undo the send. Problem fixed. In other words, without specification, there are no bugs, only surprises. Okay, so again, why do we test? After an implementation, when we have a specification, we test to find bugs. So if you, for instance, implement a calculator and you say 1 + 1 is 3, your calculator does that, then obviously this is a bug. It's wrong. And if your calculator goes 2 + 2 is 4, this is correct. This is true for any new feature, but usually we don't have only new features. We have existing systems, legacy systems. We have, like, for instance, hundreds of screens, and maybe for that software that is very large and very old, you only want to change a single functionality. Then you have to test that functionality manually, but for all the other screens, basically what you want is that it shouldn't change, it shouldn't break, it should behave as before. And what's more interesting is that after a change, if this software, if that bug 1 + 1 is 3 wasn't discovered, and the clients, the customers bought the software and installed it, and they are used to that, then suddenly this becomes the right answer. There's a saying that programming is like sex. One mistake and you have to support it for the rest of your life. And this is the same thing, right? So if your customer is used to the fact that in your software 1 + 1 is 3, then you cannot change that. You can if you talk to the customer and have a change request and do all that stuff, but you cannot randomly change it. Like if 1 + 1 is suddenly 5, then this is the wrong answer. Mind you, mathematically both are wrong, so it doesn't matter, right? Because it's wrong whether it's 3 or 5. But if 3 is the one that the customer is used to, then this is the answer he's expecting. This is the right answer, and the other one is wrong. In other words, regression testing is not really testing, because we don't look for bugs. If you find a bug like that, like if you have a release tomorrow, and you find a bug like that, and you go to your project manager and say, oh look, I found a cool bug, we should fix it, he would go, oh yeah, but not today. put it into the ticket system and we'll fix it next release, or we'll forget about it. If nobody cares. But you're not looking for new bugs. You're just want to make sure that the software doesn't change in unintended ways. That's what a regression is, right? So regression testing is not testing. Regression testing is change control, is version control. You want to make sure that the changes to your software are only wanted changes. If you improve the software and fix that bug, and 1 + 1 equals 2, and you fix that, you want to make sure that everything else stays the same, right? So it's version control basically. And there we have our oracle. Because as like Bolt Not Bug say in that they have a list of consistency oracles, and this is the history oracle. The product should be consistent with itself over time. And if this is change control, if regression testing is change control, then you can use the tools that are used for change control that are already there. For instance, if someone changes the code and you have a code base of 1 million lines of code and you change three lines, then you don't want to review 1 million lines of code. Nobody would do that. You just review the change. You just review the 3 lines. And if nothing else changed, you don't need to bother reviewing it. And that's a huge amount of effort that you can save. And this is a version control, but you also know the same thing, for instance, for Word. If you are writing a book and you give it to someone else to proofread it, and he gives it back to you, then you want to know what changed. You don't want to read the complete book again just to find out whether he mixed it up or not. You just want to see what did that guy change. And then you can accept the changes. And this is what we want for software also. Like if the software changes like that, you can review every single change, and then either it's a correct change, so you accept it, like with version control, or it's a bug, and then you found a regression. And then maintaining the test becomes very easy, because it's a single click. You don't need to like copy and paste stuff. You just accept the change. And there are already tools for that, like for string comparison, we have approvals test or text test who do that. Or if you do pixel compare, there are many tools for that. I just chose 2 of the lot. There's automated screen diff and blink diff, and there are many more. Problem with pixel compare is how to ignore, or with both approaches, how to ignore stuff and how do you mass accept stuff. Like if you change the logo on your website, then every single test fails, right? So this is a problem, but still it's very valuable in many cases. And you want the ability to ignore changes. Like with any version control, SVN, Git, whatever, you can put an ignore file to tell the system what to ignore, like log files, temporary files, whatever. And you want the same for that approach. You want to be able to ignore changes permanently. And if you think about that, it's a blacklisting versus whitelisting. So testing as we currently do it, like if you program a Selenium test and add assertions, what you essentially do is blacklist changes. Every assertion that you put says, okay, this thing shouldn't change without me noticing, right? And what we do now is whitelisting changes. We want to say, okay, nothing should change except for that which I allowed in my whitelist. And of course, you don't want to you don't want to whitelist everything. No, sorry, you don't. With a whitelist change approach, you don't want to check everything, and with a blacklist approach, you don't want to check nothing because you don't have a test anymore, right? So the best solution is somewhere in the middle, where is an ideal amount of checks. But the question is, which approach is safer? Like with one approach, you err on the side of caution. With a whitelisting approach, for instance, you can't miss the dancing pony on the screen. So Google also does this, using a pixel comparison tool in their build release chain. And when they have a famous talk on YouTube, you can find it. And he said that they did this. They introduced the pixel comparison tool because they had the problem that at some point someone put a dancing pony on the screen, and because they didn't have a check for that, I don't know why, they didn't have a check for the dancing pony on the screen, so it went right into production, and the customers found a dancing pony on the screen on their, and so they changed that into a blacklisting approach, into a whitelisting approach. And if you went to the talk yesterday by Mark Winteringham, the automated acceptance testing paradox, it's the very same thing. So that's a bad photo of one of his slides. And he said that if you have a website where you disable JavaScript and CSS, the test probably is still green, because the test usually just checks if a certain string is there. And if the string, is there, but the site is completely ugly, then still your test passes. And this is the same thing, right? There are two. You have a blacklisting approach usually. So whitelisting approach is a step into the right direction of the paradox. It doesn't solve it completely, but at least it's a first step. And then what you should think about is how much effort do you put in that? Like if you want to create a check for every single thing on the website, then it's a huge amount of effort to create all those checks. But if you have to whitelist things, it's also some effort. The question is, what's the best thing to start with? And I would argue that in most cases, what you want is more like that. So you better start off with a whitelisting approach. Okay, now we have our oracle. One step closer to bring AI into testing. But how do you perform the actual test? How do you do the testing process? And then for that we can use what is called the infinite monkey theorem, which says a monkey hitting keys at random on a typewriter for a long enough time will type the complete version, the complete works of William Shakespeare. What you then do is, with monkey testing, you just replace the typewriter with a computer and let the monkey test. And I just brought you a monkey with me, so be careful. This is what it looks like. As you can see, this is a very primitive monkey, but it fits in like 15 lines of code, right? And this is what it looks like in action. So it clicks randomly. Now I'm testing a website, and it randomly clicks on the website. And you can use this monkey to test everything. Okay, so you can test 3D action game, you can test Word, your IDE, you can test whatever you want, website, doesn't matter, and it will find bugs. So it may take a couple of hours, but it will find bugs. And it's very cheap. You can use, I don't know, an old computer that you don't use anymore, install it on there and let it run 24/7, and it will find bugs. It's just not yet perfect, because at some point it clicks on an external link, and then it stops testing my website and starts testing the internet, which probably also somebody should do that, but okay. And also it's not very intelligent. For instance, if it finds a bug, you can't ask what it did. So it only can tell you the X and Y coordinates. So it can't tell you I clicked there and clicked there. So it's not very helpful. You only get the log or the stack trace or whatever. And you can't extend it. Like you can't tell it to first log into the website before start to test. And the other thing is that you can't exclude stuff. Like if you have a print button, you probably would want to exclude that to save paper, or an email send button. You don't want to create spam and stuff like that. So you would want to extend that. And it's a really primitive monkey. It's not very intelligent. What we would want is an intelligent monkey, a smart monkey, something like that. And I even brought a basic version of a smart monkey with me. Now it looks like that. What we do here is we use a Selenium framework you're probably familiar with. And now we can't test anything anymore. So we have context, so we can't test Word or 3D action games anymore. We just can test websites. But now we have context. And now we can train the monkey to not leave our website. Test internet. We can train the monkey to first log in and then start testing. Or we can ask the monkey, what did you do to create, to trigger that bug? What links did you click, or what inputs did you make? So this is already a smart monkey. And this is how we start. And we can make that monkey even smarter by using artificial intelligence. You can use deep learning to make it more human. You can use genetic algorithms to increase coverage of the test cases. You can use all of the tools of artificial intelligence to make this monkey really smart. So then you have a smart monkey. And there are already open source products for the dumb version of the monkey. For websites, it's Gremlins.js. For services, it's Netflix Chaos Monkey. And if you have an Android app, it's UI Application Exercise Monkey. But those are basically dumb monkeys. But still, it's a start. And now we have all we need. We have all the ingredients. We have our oracle, and we have our way to execute the test. And now we can employ the monkey to our software. We can let it test the software. Either it finds a crash, which is directly a bug. We don't need an oracle for that. Like, I'm the oracle. I say every crash is bad. So we have our oracle. Or it does just generate test cases that you can run with the next version of the software. So you take version 1.0 that is manually tested, let your monkey generate test cases, and then take version 1.1 and let the test cases run again and find everything that's changed. And everything that hasn't changed, you don't need to test. So you got your regression testing done for you. This is how we solved it. Now the question is, are you afraid of AI? Well, it will steal your jobs. I mean, it will. I'm very positive about this. I think that there's not a single thing that a human can do that ultimately AI will not be able to do better. And this includes testing as well as development, as well as what a CEO does. So no job is secure. I think eventually, like in 50 years, all of our jobs will be gone. I'm serious about that. The question is, which jobs to go first? And there are even jokes on the internet about that. How many blondes does it need to screw in a light bulb? None, because automation has eliminated the need for humans. That's on SMBC. And one of the founders of the founder of Aptiv says AI is perfectly suited to replace testing. But I think, although this is true in principle, like in 50 years, the question is, how long will it take really to replace testing? And I think the current state of AI is like this. So we are not there yet. Probably AI will replace all of our jobs, but I think actually that the jobs of the testers will be some of the last jobs to be done, because there are already projects underway that generate code, so that replace development activities, and I think testers are the ones that substitute users. So someone has to test the generated code. So even if all the developers are gone, I think there still will be testers around. That's a slide of Hilary from today. You cannot automate human sense making. I would add a yet to that, but I but I strongly agree that this is one of the last things that we will be able to automate. So this is the reason why we need testers up to the very last step. So should you be afraid of AI in testing? My answer is yes, if you are a test automation engineer. Because as you just saw, what we do here is we generate automated test cases. So the manual testers that do real testing, like critically thinking and challenging the software, those are the ones who don't need to be afraid. But those who are creating test cases that run automatically, they should be afraid. And the other thing is what I call manual automates, which is, if you sit there without thinking and do manual checking Like if you have a test script and work through that test script, those are the jobs that should be really scared, but they should be already scared by outsourcing, crowd testing, and classic test automation. So nothing new here. They are already right. I think test out or AI in testing is a very good thing because it helps you keep up. Because as we heard today, testers don't create artifacts. So the work of developers adds up. Like in the first sprint, they create something, a new feature. And in the next sprint, this is already legacy code. And it needs regression testing. And in the next sprint, they create new feature, and it becomes regression testing. So the work of developers adds up, but the work of testers, manual testing, doesn't. If you have to do manual regression testing, your work doesn't add up. So either you add people, or you are bound to fall behind with testing. You can't keep up with that. So you have to use test automation in order to make sure that you can do your best and test the new features manually as thoroughly as possible, and give the rest to the AI and you know, have a regression testing suite generated for you. So, in summary, I think monkey testing is a good thing. It does it cheaper, faster, better, and it multiplies manual tests. And what we call difference testing gives little maintenance, no wasteful testing, and yet with a whitelisting approach, tests are more complete. Now I want to make a short like advertising, because I'm working with for a startup, and we are creating a Kickstarter campaign to open source some of what you just saw. So the whitelisting approach to testing that you just saw, we want to open source that, which would look like that. So you have your test, like with Selenium or whatever, and at some point you just say check, and then we check each and everything. Like, you know, you give it one thing and it checks everything except for what you said it should not, like what should be ignored. And for that we are doing a Kickstarter campaign, and I hope you will probably back us up. And it's starting in November. So you should look out for that. And we're on GitHub, and we will create checks for all of that, like PDF, HTML, Excel, XML, and for proprietary file formats. So if you have your own file format, you can implement an API and still get that checks. In order to be notified, you can just register on our website or follow us on Twitter. So that was my talk for now. I'm a bit early. Do you have any questions?
Hi, thank you. I've got one question. Well, basically I haven't got one point. How does your monkey find any bugs if there is no expected result?
It doesn't. So it finds crashes if the software crashes, but otherwise you have to manually test the software once, and then the monkey generates a regression test suite. So if you have a new version of the software, you run the regression test suite to find all the changes, and then you, as the human, has to manually decide whether it's a bug or not. So we can't replace the oracle, so we just extract it. We have the consistency oracle, history oracle, and the human has to decide if there is a change, if it's a wanted change, an improvement, or a regression. But in version 1.0, the monkey doesn't find functional errors. It just finds crashes.
Okay, thanks.
Hi, thanks for the talk. Do you know of any solution that helps automated generation of test cases, like making that monkey actually intelligent?
Yes, so yeah, I forgot to say that we are a startup. We also do that. So we implemented the whitelisting approach for Java Swing, and we also have a monkey that does the generation of test cases, and we are currently working to extend that to other technologies like web or mobile, but we are not there yet. So we have a working solution for Java Swing. Okay, thanks. Okay, any more tests? Sorry, any more questions?
questions?
Thank you, Jeremias, for